Having understood the effect of feedback and control systems, both for the non-feedback and feedback systems, so let us have the differentiation or the comparison between my open loop system and as well as the closed loop system. When I say open loop system, it is internally open loop control system. When I say closed loop system, again it is controller also included in the system. Look at the first one, the block diagram. So the block diagram, we have only G and input is R of S, output is C of S in open loop system. Whereas in closed loop, I have a G and as well as H, and there is a feedback which is a negative feedback, and input is R of S, output is C of S. So this is the first one by looking at the structure of the system, open loop and closed loop. The next is by looking at these two, immediately we can say that the feedback is absent in my open loop system, whereas feedback present in my closed loop system. The next is the control action. So you have the controller here itself, the G contains both controllers and the planned transfer function. The control action is independent of the output variables. So since the measurement is not possible, the supervision of the monitoring of the output variable is not possible in open loop, therefore the control action depends on only input of the system and it is independent of the output of the system. Where look at the counterpart, your control action depends on the actual output of the system and also input of the system. Right? Basically, I can say the control action depends on the deviation between input and output, or the deviation between the desired and actual output of the system. Now, then the next one, when we look at the gain of my open loop, closed loop, we say that the gain of open loop is more, where gain reduces in a closed loop system. This is, I can say, disadvantage of the system, closed loop case. Then again, when you look at the system bandwidth, the bandwidth of open loop system is less, that bandwidth increases my closed loop system, and the bandwidth is directly proportional to speed of the system. Therefore, the speed of the system is very less, and I can say that my open loop system is slow when compared to closed loop. The closed loop system, it is faster. And I can also say the rise time, since the bandwidth is less, we will have more rise time, whereas here bandwidth is more, we can say system rise time is very much improved, which means rise time decreases in a closed loop system. And when you look at the sensitivity, there are two things. One is for external variations, parameter variations, for internal parameter variations. Both for external internal parameter variations, my open loop system is more sensitive than what I can write here. The open loop system is more sensitive to internal parameter variations as well as the external disturbances. But when it comes to the closed loop system, my closed loop system is less sensitive to internal parameters as well as the external disturbances. This is a very important point in this comparison. So that's the reason why we are going with the negative feedback. Next, what will be the effect on noise and disturbance? So the effect of noise and disturbance in open loop system is more, because whenever there is a disturbance, noise is coming, that is directly carry forward to the output, whereas in closed loop we can monitor and we can take some action on it. So the effect of noise is less in closed loop, the effect of noise is more in closed loop. Then when you look at the other things, like open loop system is always simple and it is economical and it is very easy to maintain. Therefore, for simple systems we go with the open loop only. And when you look at the closed loop, it is a little bit complex. By looking at the diagram, it is very clear. We need to design the controller such that so it takes care about all the disturbance which are coming. Now it is complex and of course it is costly and also difficult to maintain. So in general, open loop systems are stable, but once it becomes unstable, it cannot be stabilized. Whereas when you look at the closed loop, if you choose the feedback elements improperly, so with the improper feedback elements, my closed loop system may become unstable. But even if it is unstable, there is a way to make it stable. So I cannot say that the open loop system is unstable, closed loop system is stable, or if the open loop system is stable, closed loop system is stable, because the stability depends on other parameters. It's not only the feedback of the system, whereas the difference between the open loop is only one parameter, which is the feedback. right? So that means stability we cannot justify it, we cannot say the system is stable or not by looking at only feedback, which is very important statement. Then when you look at the accuracy as well as the reliability of the system, my open loop system is less accurate and as well as less reliable, because the output is directly going, we don't have any provision to monitor the output to take any corrective action. Now in counterpart in closed loop, yes, it is more accurate and as well as it is more reliable. So these are some of the comparisons between my open loop system, which is non-feedback, and a closed loop system, which is a negative feedback system. So from the comparisons of open loop and closed loop systems, then we can draw very easily the advantages of open loop system and disadvantage of open loop system. Similarly, I can also write advantage of closed loop system like this and also a disadvantage of closed loop system like this.